Okay, I'm made the event live, so hello everyone. We're just setting up. We'll start fairly shortly. I think there's still time to get a cup of tea, though.
It is delayed.
Question, Taro.
Maybe this is not the right link.
This is the watch link.
Can you remove the watch and see if that works?
I mean, what is possible, I think, also is
Watch
just if you use the camera and then
I will get
the camera record or stream just the screen, this monitor, because the slides are not so detailed. They are just like keywords.
Do you think we can do the slides on the streaming computer? That's just the website. Okay, give me the link.
Let me know if I can help. I don't want to put too many cooks in the kitchen. Just
No
do
worries.
your thing.
Okay.
Yeah, that's that.
Oh yeah.
So
The loop. The loop. Or the loop of.
okay, here we go.
How's it going at Humboldt?
It's good. And you teaching here?
No, I do it. I finished a research project in July, and now
Yeah.
I'm working at like technical at Goldsmiths.
Yes.
But it's a collaborative.
The audio is sending
kind of behavior field, but it's a Goldsmiths or something.
here.
And also a
Yeah.
Funding because we met via the funding group.
And share
Yeah, were we applying to that one?
screen.
You can still hear us, Alex, right?
Yes.
Yes. Now we can also hear you and also the Berlin control room. So that's perfect.
Yeah.
Yay.
And we have an infinite pattern.
Sweet.
That's good to have.
Now it's time to prepare the coffee and the olives.
Yeah, okay. Coffee and olives together.
No, I think first coffee, and then people is coming with olives and probably, or hopefully both.
Happy to like connect at some point.
Okay, mute. And here we go. I just share my screen. And
Now it's more like.
yeah, it's a new tab. And in this tab, it was
It's this one. Amor, Mirdash, and then you go on Alpaca. You just write in. There's no link on the website. You write in here Alpaca 2025. Yeah, it's already there.
okay. There we go.
And
And
then you could make this full screen.
This is probably shared already, right? In the
yeah,
Okay, you can also share it in the chat.
it
or
is in the it's already being shared.
there you go.
some keywords. So,
Now it's the website.
great.
Please.
Yeah.
Yeah, they are a bit late already.
Let me get the microphone. So. Oh, great! You made it. Okay, Alex. When do you think we should start?
Should we give it another 5 minutes? I think.
Sure.
people are
However
still
much you need.
Okay, cool. So yeah, let's relax a bit and start in 5 minutes' time.
And this mic is also working, no? Yeah.
Great. Because last time.
How did it go so far? Conference in Sheffield, Alex?
Very nice. We had really nice turnout for the first 2 days in Sheffield last weekend. about 60 people
Yes.
in Sheffield each day and about the same online. And we had lots of nice festival stuff going on. 2 sellout concerts. So yeah, it was a lot of fun. The workshops were particularly good. Really amazing range of workshops. I think we had about 10 different workshops happening.
Great.
Yeah, it was good. And how are you? Everything resolved with the insects?
Yes, the insect. Yeah. That was the today is the sports event for the kids.
Yes.
Yes.
It's funny the things that get in the way of organising an event, and pestilence is one of them, I think. Sorry, I interrupted you then.
So should I just start, or Federico, you want to introduce? Or?
Yeah,
I mean, I heard that you all read. So.
Sure. I mean, when we start, I'm happy to introduce.
Okay, yeah,
the
but we wait a little bit.
Yeah, like Alex was suggesting, a few minutes. So whenever.
Great. Can we see somehow the others? Is it? Or is that it's not in the concept? So I'm used into the Zoom Zoom setup, but that's not the.
So I mean, we're afraid that let's see what happens. Like an echo.
Oh yeah, okay.
Picture in picture.
Yeah.
Do that.
Yeah. So like if we do this, you mean, then it makes.
Okay. Great.
Here we are. I think once we're going, it'll just be you. But yeah, if there's any questions from Sheffield or Barcelona, then maybe we can pop it on the screen.
After I'm finished, like I don't know, 20 minutes.
Yeah.
Talk. Then we can do for the Q&A, I guess.
Yeah.
We can do this setup. Great.
Then, because you see that the slides are being captured, it's just.
Oh, okay.
So it could work, you know.
Good.
If fun moves.
It's still sharing, yes.
Yeah.
Will you just put the Berlin presenter on stage?
So for the people at home, we're going to start in about 2 minutes, I think.
But that's possible. We don't need to.
To switch.
Yeah. Good.
Yeah, like that. Exactly. And
then I could go here on the other website. Right? Where is it?
Okay, because then you need to. All right.
I need to trigger at least. Oh, we can. What is this?
You need to scroll or something. Or
I just checked.
Okay, that works. Okay, yeah. And then when we want to see everyone, we just do this.
Okay.
Right. And then when you want to, where is it? Here. It's here. You switch between the two. View tab and view tab. There you go.
Okay.
View tab, StreamYard.
And here, that's not possible now. Okay.
Okay.
Okay. Shall I introduce Shintaro, Alex?
Yes, please.
Okay. Good morning, everyone. This is Federico Visi from Berlin at the New Practice and Design and Computation Studio at TU Berlin. And so today I'm very happy to introduce our keynote, Shintaro Miyazaki. And Shintaro is, since October 2020, a professor in digital media and computation at the Faculty of Humanities and Social Science at the Department of Musicology and Media Studies at Humboldt Universität in Berlin. And between 2014 and 2021 has been a senior researcher at the Institute of Experimental Design and Media Culture of the Academy of Art and Design at the University of Applied Sciences and Arts in northwestern Switzerland. So today's keynote by Shintaro is entitled Endosymbiotic Computation, Unlearning Alpaca Plus, Why Dissipation is Key. So Shintaro, the floor is yours.
Okay. Yeah, thank you for the invitation. Thank you for the introduction. I'm very happy that I can join in this way. And I think it will be a more informal, maybe. I prepared like 6 pages talk, but it's like an hour, so maybe it would be 3 pages or 4. My background is media studies, but I also studied musicology and philosophy. And I did my PhD on a topic called algorithmics. So I wrote the word algorithm wrongly as a musical rhythm, and was trying to kind of make a point that we also need to listen to computers and computer systems, and that this might help us to understand digital systems and computation. That was 12 years ago or more, and since then I was, like, as Federico said, in the realm of art and design research. And then many things happened. So and then I came here and tried to write a little book about how we can counterdance digitality. So that's the last book, and this was also already a little bit the question how we can do, for example, things like commoning and sharing of resources, and how we can imagine a new or different society with the help of computation. And in the new project I'm trying to present today, I'm finishing up my manuscript in German first, endosymbiotic computation. It's more also about the question of life, but it's still the same question about how we can combine computation and life and commoning. So the book has like 4 parts, sorry, and I go along these 4 parts, or I adapted for example, the Unlearning Alpaca is of course not in the book, but the talk is structured in 4 parts. So first, of course, the question, what is endosymbiosis? And then what is computation? And then the combination. And then how is this related to Unlearning Alpaca? And then the last, why dissipation is key. So it's already everything in the title. So I begin with the argument that in order to really understand what we could do and what is possible, we need to uncompute everything and so to say start from scratch, kind of theoretically, at least. And that is the good thing about theory, right? So you can really try to do that, and so you can do unrealistic things. And I started to look into biology, and since we are also living beings, and since society is made of living beings, and at some point rather late, I came across this concept of endosymbiosis. So famously, Lynn Margulis articulated her idea of endosymbiosis in the late 1960s in her article on the origin of mitosing cells, which proposed a hypothesis about the origins of cells with a nucleus, and which divides through the process called mitosis, in contrast to bacterial cells, which divide differently. And they have no core DNA. So it's about these cells which have a core and which they are called eukaryotes. And they evolved, this is the theory, from a process they call endosymbiosis, according to this researcher, famous biologist, biochemist, Lynn Margulis. This is a theory from the 1960s. And then this was, of course, very controversial. And in the 90s, the latest, it got kind of confirmed that this is really kind of, at least some part of her theory are kind of true. So endosymbiosis is the process where we can only see the result, which is a cellular component, a compartment, living inside another cell. You can see this here. With a mutual benefit for both. So, and the main thing here is this thing called a mitochondrion. So there are two major endosymbiosis processes on living Earth. One led to the integration of bacteria, which were kind of proto-mitochondria. These are these green things, compartments. They generated more ATP from oxygen, water, and other things. And the side product is CO2, right? And this is also called cellular respiration. And the second endosymbiosis led to the situation that most plants have chloroplasts in their cells, and they create ATP from light. And this was a merger of some cyanobacteria, which can do this oxygenic photosynthesis. So they also generate ATP. So anyhow, you might have noticed that ATP is something which is involved. So what is ATP? This is just a very short, I think the only quote for today, from a book by biochemist Nick Lane, who wrote many interesting books. And it's from The Vital Question, Why is Life the Way It Is? And he writes, I quote, ATP powers a change from one stable state to another, like a flipping switch from up to down. In the case of the protein, the switch is from one stable conformation to another. And to flip it back requires, again, another ATP. So this is really like a kind of a switch thing, molecular, and there is a molecular machinery in our cells. And you can see just a famous animation of this ATP. Nowadays, it's possible to visualize these molecules. You can see towards the end this kind of nanomachinery, molecular machinery. And yeah, this is just, we need to imagine that these are wobbling and it's very fast. This is the ATP, the elements involved. And so here you see this process where DNA gets copied, or at least taken apart. And for each of these little movements, you need one of these ATP molecules, big molecules. Or maybe even you need two, because you can see 1, 2. And many such processes exist in our body and in all kind of living beings, even before the endosymbiosis. So ATP was even there before, because it's also for the other cells, like the more simple cells, important. So I'm talking about these kind of cells. Maybe we had this in school, right? So this is like the kernel cell, and there's the DNA inside, and then mitochondria. They generate a lot of energy, ATP, and this created this situation that this merger was even kind of beneficial for both. And this is the basic principle of I call, or I kind of recognize, like this endosymbiotic process, because the ATP with this merger, yeah, a lot of ATP was generated, and then the point is also that you cannot, you cannot accumulate or keep the ATP inside the cell, because otherwise it triggers a kind of a toxic process. It generates oxygen, and oxygen is not so good for the cell. It creates mutations, and so if you block this process, then it gets toxic. And so the thing naturally, or like evolutionary, living cells and eukaryotic cells are then evolved that they always don't stop the process and always share the ATP. And this sharing was very interesting for me as somebody who comes from commoning, or sharing and solidarity oriented kind of processes. So it's not, you cannot accumulate, you need always to share. And this situation creates like attraction for other things which also need ATP. And then this is kind of the point where symbiosis is possible. So, and then you have from these little cells, you have multicellular organisms, which are a little bit bigger, and then you have these little worms, and then fish, and so on. And we are also like multicellular organisms, right? So that's the one part with endosymbiosis, that this principle is very interesting and kind of inspiring for maybe other structures also. And then, of course, for me, it was for computation. So then, what is computation in my kind of theoretical terms? Computation is more like a process I want to see everywhere. So the term comes from computare. Com means together, putare from Latin, like to arrange, to settle, to value, to esteem, regard, consider, judge, ponder, and to think about. So it's not only kind of calculating, but it's also like to esteem or to consider, ponder about. This is also in the word putare, and you do it together, so it's computation. It's kind of this open definition I'm interested in computation. So it's about, so computation is to think about something using calculative, algorithmic, or mathematical procedures. So we can find computing within all kinds of processes, which are firstly entangled with knowledge generation, judging, considering, secondly, calculation, arithmetics, mathematics, I already said. So computation is operating with numbers for some purpose, right? And the purpose would be if we combine endosymbiotic purpose. This is, I think I make it short. In English, we differentiate between computing and computation. The computing is rather hardware-oriented processes, machinery, and computation is a bit more open, more abstract, I would say. So in the book, I wrote like some sub-chapters about the history of computation, just to make the point that you know, how kind of narrowed down this computation became, and how kind of tightly coupled it became to capitalism and the execution of powerful extractive operations. I think you are also familiar with these kind of, you know, studies and theories. Maybe I just make it quick. So I start with computos around 1000. So computation then, back then, it was like about the calculation of the Eastern dates. So when is Eastern? And the church was kind of using clever people to calculate this. The problem is with the moon cycle, and that the moon cycle is shifting, and you don't know exactly which date Jesus was kind of how to say, crucified. And there is no exact date. There's only this kind of stories around. It was like close to another Jewish day, and this is connected to moon cycles. Anyhow, so this is Computus, which was already kind of entangled with power church. Then around 1300, we have this kind of influence from the Arabic Indian numbers, and the guy the Arabian scholar who kind of wrote a treatise about using arithmetic numbers is called Algorithmic, and the Latin translation was like Dixit Algorithmi. This guy said, and then this kind of got abbreviated into algorithms. So what we call algorithms nowadays comes from this kind of process, which is like using numbers with our numbers we have with 1, 0, 1, or 1, let's make 104, and then you can write down 105, and then you can do addition, right? And then you have the positions, and all these kind of systems comes from this time. Then we have double entry bookkeeping. This is also an interesting process. The division of computing, which is related to Adam Smith's division of labor. So in around 1800, you have already little manufactures of calculation, where they kind of calculated trigonometric tables, in which were used to calculate in cartography to calculate the fields and so on. And then finally, the 5 and 6 is about what we usually talk about when we, in terms of computation, is the Turing machine, and then of course digitalization, and how this kind of developed into our current state, where I used the theory of Mackenzie Walk. She talks about vectorialism nowadays, which is like another layer of which comes to capitalism. I think maybe you're familiar with this theory. Just wanted to mention it. So this is just to make a long point, kind of short, is to that's computation is kind of narrowed down, and let's try to unlearn computation and think what is different, what is possible otherwise. So this idea with the endosymbiotic computation is trying to reglue and repair what has been taken apart. And this is also what I mean a little bit like as a provocation, that this would also involve unlearning Alpaca in terms of algorithmic patterns in the creative arts. So how can we imagine new practices where we use different means of computation? This is also something I would like to discuss maybe with the people here, or just like propose as a question. And in the book, one way to do this, I call is an approach I get inspired from Deleuze-Guattari, minor literature, and I call minor coding or minor programming. So minor is in contrast to major, which is the default hegemonic identitarian, you could say, or fixed, always dogmatic kind of male white supremacist perspective. While minor is always it's not the opposite approach. It's the opposite, but it's always changing and it's kind of ever fleeing. So minor cultures and minor approaches are always adapting, critical, and against the mainstream approaches. And I would like to see this also in Alpaca. That's kind of the proposal. And this is inspired, just to dive in a little bit more, from Deleuze-Guattari's analysis into Kafka's work, Franz Kafka. Kafka was like writing this kind of counter words or kind of analysis of, for example, bureaucratic problems, right? We also, some of us face, for example, if we go just to the immigration office and so on. So these kind of bureaucratic systems, Kafka was very interested in and tried to analyze. And he created this kind of, using his writing and stories, he created these kind of counter machineries where he proposes different ways to tackle these things. It's not so direct, but at least he shows that it's kind of crazy, right? And in this kind of similar terms, you can apply this kind of idea to to minor programming, which would use, for example, still use major languages like C or Python, whatever, but to create counter words like games or applications, workshops where you, for example, criticize or which are against fascism or which are against this kind of hegemonic structures. So, for example, also minor, you can also use, it has a musical connotation, right? So the minor chord is already diminished and triggers kind of in the theory of Deleuze-Guattari, you would call this deterritorialization. And the major chord is kind of fixed and, is stable. So it's about making things unstable and taking apart, but then also putting them together again in a kind of careful way. If you put them together in kind of strong way and make it really freezing, then this is fascism. So this is kind of, in simple terms, the theory Deleuze-Guattari. Of course, you can make them fixed, and stable, like in music. This is important, right? But it's you can always change it a little bit, or you can make a new progression, or you can try it out differently. But if it's like really conservative, the attempt is really to conserve exactly this style or this piece of music, which is, I think, in music never the case, because you always reinterpret it, and like even in classic music, right? And and music also for Deleuze-Guattari is a very important field. So there, if you're interested and read Gilles Deleuze, Félix Guattari's work, there are many kind of metaphors or many things which are useful for music signaling aesthetics interested people, like patterns, pattern interested people. So are there like useful examples for this kind of, for my idea of endosynthetic computation? And this is kind of the question, right? And then I was trying the book, I was trying to find, I was writing about examples from two fields. Very simple, I categorized them with data analysis and modeling. And so new ways to do data analysis, new ways to do modeling. I talked about, or I wrote about, sorry, for example, something like, which is called paleogenetics. So archaeogenetics is the kind of analysis of using ancient DNA which triggered a lot of kind of questions about our humanity, right? So who are these Neanderthals? Are we related to them? Yes, we are related to them. Did they use this and that? And then also another humanoid kind of species appeared, the Denisovanian, and so on. And this was all everything triggered by this paleogenetics, which was kind of using a lot of statistics and a lot of computational methods, but in kind of a simple term, in simple ways. I would say it's so that I categorized it as data analysis, kind of new ways to do unstable or destabilizing usages of data analysis, which then kind of changes the knowledge kind of very fast. Because it was assumed that Neanderthals and Homo sapiens never kind of interbred, and so on. And then the next field is modeling. So I was looking into agent-based modeling, for example, the uses of agent-based modeling in archaeology to change also kind of fixed ideas in archaeology. And agent-based modeling is enabled the researchers to simulate things, and then maybe it was different, and to make a point that it was indeed not as all the people, all the researchers imagined. Then in a little bit connected field is the cellular automata field, artificial life, where it's shown that actually many things are possible. There's a whole virtualities of many possibilities, but the problem is how can we kind of make them real, right? So in the computer, you can do actually, you can simulate artificial life. You can simulate this kind of evolving cellular automata, which kind of behave like, you can program them like as they would behave like they would be Turing complete. That's always what they want. So that it's kind of equivalent to the computer, to the Turing machine. But this is kind of also a dead end because, yeah, the question of how to actualize these kind of virtually worlds into something real, that's kind of question of energy and so on. And then I finally turned into a field called companion modeling, which is very interesting. So they use this kind of agent-based modeling, but also other modeling techniques, simulation, in the field of development or kind of ecological questions, and do kind of participatory research with stakeholders. And they use simulation and agent-based modeling techniques. So agent-based modeling is this, which maybe you know with the birds, swarm modeling things. They use this kind of agent-based modeling to analyze their problem, which they have, the ecological issues, and then try to solve them together with those people who are involved in these issues. And this is kind of working quite well at some point, until some point, and this is called, or some French researchers call this approach companion modeling, which I found very inspiring because of Donna Haraway and so on, this companion idea. So these are these two parts, this book chapter, which is like about, yeah, other ways to do computing, but kind of using computing, conventional computing. Then there is also this field called unconventional computing, which is also very interesting, which is like looking into cellular computing, fungal computing, and so on. This is inspired by a guy called Adam Matsky, unconventional computing. Here's also the issue is, at least in the next 20 years, it's not so fast realizable because there are some issues like if you have DNA computers, the problem of the DNA is like you need a lot of DNA, and this would use a lot of space, for example, or fungal computing is just very slow. You know, the mushrooms, they calculate very slow, and this is also not useful for the conventional ways to use computation, but maybe just for inspiration, this could be interesting. And then I skipped one part. There is also alternative uses of conventional computing, like slow computing, permaculture computing, and other things where they use current hardware servers to create alternative usages, like, you know, they share servers and this kind of more like free software movement field. But still, this field called permaculture computing, this is also very interesting. You can ask me, or you can write me an email afterwards to get these kind of references. The talk here is kind of reference free. I'm sorry, but you can always send me an email and ask about where is the source of this. So then the question is for here Alpaca, and also I'm going towards the end. So how we can, if we have this kind of two fields, very simple field, data analysis and modeling, how we can relate this to computer music or pattern generation. So then I thought maybe for the first field, we could look into alternative ways to play back data, sonification, modification, new sonic interpretations, question mark. The second part is about modeling, how we can incorporate modeling into computer music. It is already there, but how you could make it, you could open it up. So it's about the way how an algorithm sounds, how a model sounds maybe, or maybe it's also about how to learn to code this kind of model, which is also important for different ways to use computation. Similar like what I meant with companion modeling, but for sound. So you could do sound workshops, pattern generation workshops, which are not only about generating new patterns or interesting things, but which have kind of a political, agenda, and maybe use kind of this idea of the endosymbiotic computation. So the endosymbiotic computation, just to make it clear, I think it's not yet clear, but it's this process of nesting processes, nesting, entangling, using compartments, but then also not just letting them close, but come up with a new compartment, which is bigger than the one before. And this process could go on and on, because this is, at least if it's a living process, because we have also this principle of dissipation, which we are also part of. So there is the sun, right? And then there is entropy, but living beings are creating order for a short time, but there's always things leaking out and dissipating, and this dissipation is also kind of wanted, because the main idea is to go towards entropy, right? Or it's not the idea, it's a principle, a physical principle. So, and living beings are always creating more energy as it's necessary. I'm like, if I'm talking, I'm sweating here, so I'm generating more energy, more dissipating more stuff as it's needed. And also, this is done with music, with concerts, for example. You cannot close up a concert. It's the sound gets out a little bit, and people can also listen from the outside. And so this is also, for me, this is connected to the sharing and to what I call becoming common or becoming mean, becoming medium. In German, it's a bit more obvious. I call it gemein werden. the word gemein has this meaning, this double meaning, and is similar to mean. So you are mean, and the mean value, right? And this is another story how this kind of mean or common gets into this negative connotation. It's related to aristocrats, bourgeois people who just just don't want it to, who just try to to introduce a counterculture where the exceptional and the aristocrat are kind of the better model, and the common and the mean is just, it's not the way to go, because they were not like that, and so that nobody could kind of tell, how to say, accuse them that they are not common. So for me, this is everything connected, like the commoning and this kind of endosymbiotic process. And this is sort of what I is kind of wobbling, this cloudy thing called endosymbiotic computation. And also like this idea that we humans, or yeah, we can, citizens, we could create try to create the next kind of endosymbiotic merger, not like the top-down merger, which we are born into, like the, the state or the society, which is like, something top-down maybe. And one important principle of this endosymbiotic process is that the mitochondrion, the smaller unit, has always the control of the whole thing. So if something in the mitochondria goes wrong, this is very bad for us as living beings. So like we need to build structures which are somehow similar, like this, how this works. And so we would need to make a kind of architecture where the citizen has really the control over the larger, the meta entity. And of course, everybody will say, yeah, this is not going to work, or some will say this is not going to work. And there is also computation is needed to show with models and with games that it might be possible, and to kind of pre-exercise these kind of things. This is what I kind of try to write about in the book Counterdancing Digitality, but it's also still here, like this usage of modeling and computation to make a point. Which is, of course, on the other side, it's always used from the economy or for marketing purposes. There are always models behind their kind of rhetoric. But from the activist, leftist, environmental movements, there are not so many models involved, at least not those which are kind of agent-based models. Of course, I'm like spontaneous now. I'm thinking about that's a little bit wrong, because of course, environmental scientists, they have their large models which show that it's going to not work. But it's a bit too simple model, I would say, and we would need other models which are closer to our daily life and our micro politics. Yeah, that's it. Thanks so far. I have this Blue Sky account. You can contact me, or you can write me an email. And I'm looking forward to the short Q&A. Yeah.
Thank you so much, Shintaro. Thanks for that. Oops. So we can have, we can see also our remote guests on there. If there's Alex, Barcelona, here we are. Yes. Okay, great. Are there any questions?
Comments.
Comments here, and Alex is raising his hand. Alex.
Thank you, Francisco. Yeah, thank you for that really wide-ranging talk, Shintaro. As you were going through the kind of history of our different understanding of computation, I made me think about the fact that history also obviously is a power structure, and people have been calculating things perhaps without writing them down, without it being part of the historical record. And also practices like the kipu in Andean culture, where things are recorded in notes rather than in writing, and musical algorithms which are embodied and sort of taught through practice rather than written down, and perhaps have less power than score-based music. Yeah, just wondering if you had any thoughts about, and this kind of endosymbiotic thing seems to be a kind of live process where the kind of calculation or the processes are part of the thing that is being sort of described by the DNA. Sorry, not knowing the biological terms. So yeah, I'm just kind of interested in this kind of alternative as something which is live, and also is the actual notation is continually changing as part of that process, whether that's part of this endosymbiotic process that you're describing, the sort of liveness of it, and the lack of separation between the algorithm and the process.
Mm-hmm. The last point I didn't get, but the first, maybe you explain it again then when, so the first point I get, the question about kind of alternative is not the nice word now, right? But otherwise, alternative histories of computation. Sure, yes, this would be another book maybe, or another project to look into each fields where are actually other ways to do computation which are not following this thread I kind of showed. For example, this kind of Latin American indigenous way with the the threads. This might be one. Other forms. Yeah, I would really need to look into kind of the archive, or investigate a little bit more. One thing I described in a book, which I skipped a little bit, is this field where they used agent-based modeling for also simulating, or like for confirming the possibilities of, for example, matrilinear societies, matriarchal societies, or societies, hunter-gatherer societies, where there was a rule to share everything always, and these kind of things, it's difficult to find in the kind of the archaeological record in the material, but you could simulate then and then compare other things. And this is also the usage of agent-based modeling, for example, for this kind of alternative, not history, like prehistory or humanities, history of the humanity. This is something I'm very much interested in. But I skipped the middle part a little bit.
Okay.
So like the middle part from I don't know 5,000 before Christ.
Okay.
But maybe before. So the large story is like, right, is this kind of emergence of agriculture, and how agriculture emerged, and then the change from the hunter-gatherer society into the agricultural society. And then also this kind of shift between nomadic ways and then cities or kind of settlements. And one large settlement, which is very interesting, is Katalhuyuk, or something similar. It's a city in Turkey, which existed. It's one of the oldest cities in the world, and they had houses which, so they had no streets, but it's a gathering of houses, and they were entered through the roof, and in the house there were the people were buried into the ground of the house, and then they tried to, with DNA analysis and so on, they tried to figure out how the people are related and so on, and they are not always related. So not always the family is in the ground, and this is kind of was very interesting for me also. So then the question was how this got organized, and maybe they had like a system where the children were growing up somewhere else other than the family, to maybe reduce this kind of accumulation of wealth or of power. And this is kind of evolved as kind of a mechanism, an algorithm in order to have a egalitarian society. So this is very kind of very interesting, and these kind of things are in the history, and of course you could look more at it, but it's great. We should do more of that.
Is it okay if I come back, Francisco?
It's Federico here.
Oh, Federico, sorry.
That's all right.
Sorry, it's still early. So with the Kipu, that reminds me of the IU structures that are the kind of alternative, so to say, structure to the state in Peru and other Andean region in general, I think, where indeed it's not a top-down structure, it's still a tree structure, but decisions come up through family groups. And this is related also to the Kipu, because particularly the sort of pre-Incan civilizations would use the tree structure of the Kipu, I think, to represent these sort of civic structures. And talking with Paola Torres Nuñez del Prado, who does a lot of work around the Kipu and electronic arts and things. And also Dave Griffiths, it was interesting connecting that with the structure of Extinction Rebellion, who have a similar kind of, I think they call them rebels or something, and may well be sort of inspired by these other civic structures. With Alpaca, it's interesting to think about how these sort of patterny communities can be dissipated, but also connect together in this sort of bottom-up way, which I think is something really worth exploring as a community of practice. How things can be decentralized but still connected in these networks.
With the tree, you mentioned the tree concept. So this was also in ancient DNA one point, that the humanities maybe it didn't involve in kind of a tree structure, but it's more like I don't know what they used. It was like I forgot the word, but it's more like something where everything is connected to everything, So it's not rhizomatic, but close to rhizomatic structure. And then there, of course, before the eukaryotic emergence of the eukaryote, the bacteria gene transfer is very chaotic and very non-tree-like.
If there are no other questions, I would ask a question, which is actually maybe more like, to elaborate further on this exchange you had with Alex, where you also touched on, ancient societies going from hunter-gatherers to agriculture. So, I wonder, if you could, perhaps, if you'd like to tell us something regarding like contemporary society and something that perhaps you're seeing through the lens of endosymbiosis, like so contemporary processes in terms of, you know, algorithmic processes being embedded in contemporary societies, and if you could comment on anything that you're seeing in contemporary society. Yeah.
Like bad examples or positive?
Yeah, I didn't want to, you know, I didn't want to, as it's like influence your take too much. Like, okay, tell us something bad or something good about it. So, like, I would leave that to you, actually.
I mean, we are always in the situation, right? So that's of course I recognize, and of course it's very difficult. But one field would be which is not related to aesthetics, unfortunately, but like financial markets. It's crazy. What's so crazy? What happens? And it's all algorithmic, right? And it's about digitization and even money or this financial capital nowadays is data and is very detached from material things.
Yeah.
So this is a bad example, but there you could also, since we can do this somehow, since 500 years, maybe this is, we could organize this similar to how ATP is organized in life. So instead of, you know, accumulating the money, I mean, we just can share it. No? I mean, it's a very simple, stupid idea, but maybe we can, for example, we have tax.
Tax.
So why not, you know, really have tax, how to say, not solidarity, like rightful tax, right? So that those who, because the rich are not taxed correctly, right?
Yeah, that's evident given the increasing wealth gap.
Yeah, justice, tax justice, what I wanted to say.
Oh, okay.
So, and we could just make some models and show everybody that it's possible and it would have this and this benefit. I mean, this is something like a political party could do very quickly, but it's not used. This kind of modeling is still not used in this kind of context. So this would be a very simple, very first step to use computer models, agent-based models or something, just to show that this could be possible and this would have this and this. Not only just show the numbers, because they are also convincing, but maybe we want to see how it would develop in kind of certain time frame with certain steps. Maybe we can even have a plan and then say, first we introduce this law and then this would happen, and this could be part of a simulation, part of a game, and people could play it or show it. So this is one way.
Yeah, that would be the positive, right?
That would be the positive.
Thanks.
And then in terms of computer music, it's a question. I mean, music, I like music because it has this dissipative element already in, and it's effective. But it's also dangerous that it's effective, right? You can also use it for other political purposes, but that actually, at least you can connect via sounds, via signals very easily. This is the one great point of music.
Yeah, I agree. Music is great,
and it's contagious. And it can spread.
So like you contagious. You see, like also music as a kind of agent for some kind of what would you call it?
Like a kind of thoughtful revolution.
Yeah. Right? Nice. Okay.
Like the rave,
the rave as
counter rave movement. I like when in some years ago when Brexit was introduced, there was like many raves against this. But this is the affective part, and in the last book, the one point is that this is of course useful, but we should be also careful. And then this idea is to use modeling and software
Yeah.
simulation,
Uh-huh.
the power of computation to get more reflected, more kind of rational and not so just outrageous, like,
Yeah.
just not just raging,
Yeah.
raving.
Yeah.
You can do that.
To imagine what happens after the rave, you mean? Like,
Yeah, to imagine or to rave in a way that it's not only like, I don't know, disruptive for some people, but maybe it changes things.
Yeah, exactly. Yeah. That's the thing that Zizek often says. I want to see what happens the day after the revolution, right?
Yes, yeah. I mean, revolutions are possible, but the day after the revolution, that's always the problem. And
yeah, exactly. Great, thanks. So, like, the book you were referring to is your Counterdancing Digitality?
Yes.
Yeah. So, Counterdancing Digitality, I'll do a little promotion for you. It's open access online. You find it if you just use your favorite search engine and type in Shintara's name and Counterdancing Digitality, it should definitely come up, and it's open access, so anyone can get a PDF for free. Is that correct?
Yes. And this one will be also, I hope, end of 26 or maybe later in English. An English version is planned using BRT computation. Also open access, hopefully.
Great, thanks so much.
Okay.
There was just a procedural question from Stephanie. Is there a paper for this talk, or is would you like to share a text for this talk, or is it best just to direct people to particular writing you've already published?
You can write me an email. The text is really sort of chaotic, and it's what I read, so I can share this, but it's not really informative, I guess.
Okay.
But yeah, I could, if there is a proceeding or something, I can write it up for.
Yeah, we can publish it as part of that. Yeah, we've got. Yeah, we can do it.
It's a bit too early for me, but I could think about. Yeah.
Cool.
Awesome. Thank you so much. Are there any more questions? Yes, actually we have.
Great.
Okay. A very interesting talk, as much as I could understand.
Okay.
You said something about the individual being important, but then again you said that average and mediocrity is like a bourgeois term. You said like mean.
Yes.
It's a bourgeois term, and it has a bad connotation.
Yes. But we should reactivate it.
We should reactivate it, but then the individual.
Good meaning.
Okay. Why?
Because
you said the cell dies without the mitochondria functioning or something like that. You said that the smallest part is very important.
Yes.
So the individual.
Yeah.
But isn't this a contradiction to the mean? I mean.
Okay. Yeah, but the smallest part, we need to also act. The small parts are acting together.
Yeah.
Somehow, against the larger part. It's not only one. One mitochondria would be have no effect.
It's lonely.
They're very lonely. I mean, there are always many. From the mitochondrial cell, from the eukaryotic cell, there is not only one mitochondria there.
Yeah.
There are like 50 or maybe 200 or even more, and they are also connected to each other somehow. This is like also kind of speculative research or very recent research, but there's a lot of interesting stuff with how the mitochondria connect to each other. So this is then the common.
Yeah. And relating to Federico's question about social algorithms, how do you feel about Spotify?
Spotify is, I don't know, maybe useful for some people, but it's pretty clear that.
But for music, I think it's not that.
It's
beneficial.
Not
it's not beneficial.
Not
for
beneficial.
Music.
No. Absolutely no. Of course, it's within the capitalist apparatus.
And I wish I learned more about. You said something about computer permaculture.
Yes.
Is that a thing? I can research it online. I never.
You can look at either permacomputing or permaculture computing. It's inspired from permaculture, gardening.
Yeah, I know.
And then the idea is how they can import this into computing.
Okay, so it's like using the same technology for longer or something like
For
that.
longer, more sustainable, but
Uh-huh.
also repair it, use it, not make a monoculture, not on, these kinds.
Okay.
And you can read about there's a series called Counter N and Counter Computing, which is also on my website, but also you can find it.
I will look it up.
Counter N is this series I do with Eyül, Osking Eyül Isen, and we have like interviews and conversations with about these kind of combinations.
Okay.
Counter computing, many possibilities.
Thank you once again.
Yeah.
Really interesting stuff.
And this idea with the streaming, there was also there are ideas to do like cooperative streaming platforms, but often they fail because of financial reasons and so on.
Yeah. Well, I thought about Spotify because I just read this morning that Massive Attack just withdrew from Spotify because they're sponsoring something.
There's there are critical books about Spotify.
But for musicians, it's really bad.
Yeah, there's also a book, something in direction of disentangling or dismantling Spotify.
Mm-hmm.
It's published by MIT Press.
Okay.
So, and this is already 10 years old. I think.
Yeah. Okay. Thank you so much.
All right, great. How's it going wherever you are?
It's well in Sheffield. I think we're 20 minutes behind, so we should probably go straight into the next session. But thanks again.
Yeah, thanks, Alex, also for the invitation.
My pleasure. I'll email you with some.
We stay in contact.
Yeah, for sure.
Yeah. Okay.
Thank you very much. So no time for breaks, so everyone. But we have our next presentation, which is pulse pattern permutation, applying Schillinger's pulse interference and computer assisted composition, with David and Alan, who I believe are with us. I shall find. Yes, I see you there. Hello.
Hello.
Yes.
Hi.
So here's your slide. I need to remove these ones. Excuse me a moment. Right. So would you like to introduce yourselves and take it away?
Sure. Hi, Alex. I'm David Chechelashvili. I'm Alan Brown, and we are talking to you from Auckland, New Zealand, where it's currently just after 10 p.m. So thank you so much for having us here. We are both lecturers in music and music production at SAE here in New Zealand. And we will be presenting our paper called Pulse Pattern Permutation, Applying Schillinger's Pulse Interference and Computer-Assisted Composition. This is a project that Alan and I did over the last sort of 6 months or so, where we tried to put some of Joseph Schillinger's mathematical compositional ideas into software, sort of digitize it, so to speak. That's our talk. So I can drive the slides here, can't I? Yes. Okay. All right. So I'll just start at the beginning here, and Alan and I will sort of co-present this as we go. But essentially, hi, Andrew. Essentially, our idea was to explore rhythmic generation or algorithmic rhythmic generation in computer music composition. And for that task, there are lots of approaches, as you probably are aware, all sorts of genetic algorithms and probabilistic stochastic Markovian processes that allow for generation of interesting and complex rhythms. And we took a slightly different path where we looked at Joseph Schillinger's system. Joseph Schillinger was a theorist and composer in the beginning, first half of the 20th century. In 1941, he wrote his first volume of the Schillinger's composition system, and he sort of wanted to combine mathematical rigor with musical creativity. And in 1943, I believe he wrote the second volume to that work. I think combined sort of 1,500 words or so of a comprehensive work in trying to relate mathematics and numbers to music. I suppose right at the top, it's worth saying that in Schillinger's mind, his system wasn't sort of a replacement to traditional harmonic theory. It was just there to aid composers to maybe break out of habitual ways of structuring their music, both rhythmically and harmonically, and in terms of its form as well. So while it was this all-encompassing comprehensive system, in our work we're using a very narrow, just sliver of his ideas, and that idea is what he calls pulse interference of integers in order to create rhythmic patterns. Pulse interference is a fairly simple idea. The idea is that you would take two pulses at different frequencies, and then you would play them together, and you would get a third, more complex rhythm. And so this was his way of combining these these varied rhythmic patterns to create polymeters and syncopation, all sort of with this certainty of mathematics behind it. So we took this idea as our point of departure, and yeah, went from there. Essentially, the process involves very simple mathematics. We take, to start with, for example, a time signature, common time of 4/4, and according to Schillinger's system, you break it up into its combinatorial pieces that are non-even pieces. So in 4/4, you couldn't have 2 + 2, that wouldn't work. It would have to be 3 + 1 or 1 + 3 to make up the 4. And then you apply some algebraic processes like squaring and expansion to create these new rhythms and new scales. So the process itself is described in a bit more detail in the next slide, and I can see, I'm pretty sure I had some audio examples here that don't seem to be embedded in here anymore, but I'll talk through it, no problem. We've got some video examples later on. Yeah, let's say we take this 4/4 time signature and divide it into 3 + 1, and then you square it, right? So if you square, remembering high school algebra or maybe middle school algebra, a + b squared, you could get this longer equation, a squared plus a times b plus b times a plus b squared. And so if we apply that to 3 + 1, we get this these factors. And so 9 here is the duration of a count, right? So if this is a 16 count 4/4 pattern, for example, or length, then the first event would happen, then it would last for 9 counts. then the second event would happen, would last for 3 counts, and another event would last for 3 counts, and the final event that would last for 1 count. And so that is now a rhythmic pattern that we derived by doing some basic maths to the time signature. And of course, we can reverse this, right? So we can play this pattern backwards. So you'd get 1 followed by an event that lasts for 3 counts, and another 3 counts, and then 9 counts. And then if you took these 2 things and you created an interference pattern from the 2 of them, it just means you play them on top of one another, which would give you this more complex pattern. So in this picture here, the diagram sort of shows a 16 count 1 bar, and then here would be the the 1-3-3-9 pattern, and then the 9-3-3-1 pattern, and the orange pattern would be this expanded big pattern here. So you can imagine sort of what that would sound like.
Yeah. Plus the idea that Schillinger was about with that integer combination was really to develop some sort of balance. And you can see with the generated numbers at the end, there's a palindromic equilibrium to them. That was what he was about, was creating some sort of balance within a rhythmic structure by this algebraic process. Yeah.
Yeah. So yeah, this pattern, of course, is symmetric down its middle. Here, it's same backwards as it is forwards. So yeah, he was sort of preoccupied with these ideas of having this mathematical integrity to music. In terms of our implementation and the way that we put it together, we built a fairly simple pure data patch that would do all that maths, and that would generate MIDI notes from those rules. We also added a couple of real-time switching abilities to the patch, just so we can sort of almost improvise some of the elements of the patch, and then using sort of MIDI over Bluetooth, we connected it to an iPad running AUM synthesizers for our final performance, where we get some of our examples that will follow. The patch looks like this. I sort of made it deliberately a little bit messy, almost to sort of track what's going on with it, and basically just to explain through it. And I won't take too long here. So these you can the A, B, C, D, E, and F, you can sort of think of as individual voices or individual pattern generators. And it's all hard-coded so that a pattern like 9331, for example, goes through this. There's a tempo for it. I think in the video we also have a metronome, just so you have some kind of a back beat you can reference while listening to the patterns. And yeah, so in the previous slide we described 4/4 time signatures, but we also created one pattern for 3/4 and one pattern for 5/4 time signatures as well. I think the next slide is the example, the rhythmic example. So if I hit play, I've uploaded these videos. Alex, maybe you can help here. If I hit play on, there you go. So now we're hearing the metronome, and this is the pattern 9331. And then both play together for that combined pattern. Okay, I'll stop it there. Yeah, you could kind of track the call and response, this palindromic pattern that Alan mentioned. maybe with the first two patterns, and then this one just plays a different time signature. But once again, sort of all agreeable and all work with one another, or at least that's what Schillinger would have us hope and believe. We then took this idea and expanded a little bit further to include not only rhythms and time signatures, but also to generate some new or novel modal scales. And Ellen might talk to that.
If we go back to the presentation slides, we can do that. There we go. So if we go to the next slide. So the idea with this was Schillinger also uses the idea to try and create melodic scale forms from the same type of rhythmic patterns. And he did this by, and it could be done simply enough by a simple subdivision of the time signature. But to create more interest, one approach was to divide the octave, which is 12 notes in the octave, there are 12 intervals within the octave, and to an unusual combination, in this case 7 plus 5 or 5 plus 7. Other examples could be used, but I mean, and generally in Schillinger, the idea was that the integers shouldn't be multiples of each other. So that's why we get these odd and interesting variations. So by doing that, subdividing these intervals and to a 7 plus 5 and 5 plus 7, we do the same interference pattern. We get the sort of common 5 to 5 variation from that. Now 5 in terms of intervals, quite a large interval of 5 semitones. The idea was then to actually create permutations of the 5. So just by sort of quintinomial permutations, take the 5 into a 3 plus 2 or 2 plus 3. So we end up with a sort of 5 interval variation, 2 plus 3 plus 2 plus 3 plus 2, or whatever it might be. And that creates various scale forms. If we look on the next slide, you'll see those here. So the first example, 2 plus 3 plus 2 plus 3 plus 2, gives us a pentatonic scale, 5-note scale, 6 notes including the octave. And by these various permutations of the 5, I should say, we get various other scales, which can be interpreted in respect to belonging to some other pentatonic scale. But the idea with Schillinger was that these have a degree of coherence because they are derived from the same schema. And that then they belong to each other. So you have the major and the sort of minor pentatonics and the sort of dominant pentatonics all together. And that's what we used in creating these examples of, and also improvising by sort of spontaneously triggering the different modes or different pentatonic scales as we went with the various examples that we've got. And we can probably show a couple of examples from here. So if we go to the
plucked synth
example that's there. So you can see we were varying some of the modes, PD scales, as we went, just to create some of the variety from those various scales that we generated. The scales could be much more complex than that, but we just sort of went with the pentatonic idea because it's sort of the simplicity at this stage, and the pentatonic scale being sort of foundational scale for all sorts of musical approaches.
Yeah, just to show off maybe its versatility in different contexts, we also applied the same patch essentially to different sonic material, like in context of maybe more ambient music. We have the next example that we can just play briefly, maybe only about 10 seconds or so. AUM synthesizers in and then just to also try something else, we've created or applied this patch to examples with just a string quartet, violins, violas, cellos, and basses. That's the next video example, please.
Yeah, just to say you're into your question time now, but feel free to carry on.
Yeah, well, let's in fact go back to the presentation then, and we'll wrap it up. Thank you. We are at the end here. Whoa, that's gone a little messy. Yeah, I just wanted to highlight as sort of concluding remarks here that this application is not about fidelity to Schillinger's system in some kind of a dogmatic way. It's just a way of showing a historical method that can still be used in modern music making, and even according to Joseph Schillinger himself, who was a reasonably contentious figure, he wasn't interested in replacing anything. The Western tonal harmonic theory is just a way of inspiring creativity, inspiring that next step in composition.
Yeah.
Yeah, I think that's us. Happy to take questions. Thank you.
Thank you very much, both of you. So, yeah, any questions here or in Berlin? Not sure. Oh yeah, Berlin control room.
Still in Berlin.
Yep. We have one. Yeah.
Hey, thank you for the wonderful input. I'm just curious if you ran out of time and you also applied this this pattern into the timbre aspect, because I saw about the tonal pattern, the rhythmic pattern, and I was wondering how it would be to be applied in the character of sound in terms of like harmonic distortions or so on.
Yeah, absolutely. Yeah, we actually had another audio example that was applying these patterns to various synthesis parameters, essentially. So we took a reasonably boring synth patch that just sounded like a sawtooth with a bit of filter on it and just a pad, and just used this patch to animate its various parameters. Things like FM amounts, or like you mentioned, harmonic distortion and things. And it's pretty interesting. I think it's about managing ranges at that point, so things don't go too crazy. But maybe too crazy is exactly the point. Yeah, it's I think it pays dividends. Yeah, it's a really interesting place to take it. I think this was one of the last things we sort of thought of, and immediately went, we should do something here and do a little bit more work on that side of things. Yeah.
I think that would be a nice prompt to play the video, if that's okay with you.
Yeah, I'll just add it to the presentation.
Is it the strings one?
No, it's not the strings one. It's actually where can I find it?
That one?
Yeah. Can I just drag it on to here?
Try.
Oh, I'm afraid. Didn't quite happen.
Let's go from the
just
desktop.
1 second. Sorry.
There it is.
Here it is.
Ah, yes.
It's just a visualizer with audio.
So is this Terra patch example?
Yeah, Terra. Yeah, it's about 10 seconds of or 8 seconds of basically the patch without any changes. So it's just a static sound, and then animation happens.
Okay.
It's a fairly long. I'm sure you get the idea. We'll stop it there.
Yeah,
that's enough.
Yes.
Thank you.
Just a nice moment of contemplation of that. Yeah, I was just going to ask about the. Oh, actually, there's probably a better question from Ivan. Let's see. In the synthesis example you're mentioning, how do you select the synthesis parameters for using the method?
It was sort of fairly arbitrary at this stage, although we obviously were looking at things that would create the sort of color contrast that we were after with such a static sound source. So things like, filter and resonance and those sort of things, and subtractive synthesis, but also, trying some different parameters that were available and just seeing what the results were like, but using still the algorithmic sort of changes. As David mentioned, it sort of, you've got to tame it a bit. It can get out of control a bit, but I mean, depending on the circumstance, that could be a desirable thing. So, I mean, you could potentially sort of select particular parameters that are applied for a range of different sounds and keep the same parameters, I guess, as one approach.
Great stuff. So unless there's any question, one more question from Berlin. Yeah, I was just going to.
Is it possible to find this patch somewhere and experiment with it at this stage?
I mean, I'm happy to share it. It was such a. It's fairly easy to recreate, and like I mentioned right at the beginning, it sort of is hard coded. I think the next step would be to make it a universal patch in the sense that you could type in the time signatures and then it would do the permutations. Currently, it's actually only doing 1339 and 9331 and so on, right? The examples that we used in the paper. Yeah, it wouldn't be. I think one of the draws of the system is the accessibility of maths. How it's not that complicated, you can sort of do it on a piece of paper and apply it like that. So in terms of the PD patch, I'm more than happy to share it if there's a mechanism by which to do that.
Thank you.
Great, thanks. All right, shall we move on to the next speaker, because we're more than 20 minutes behind?
Yes, so Tonya, let's find you. I can see.
In the meantime, I shared the link to the paper by Alan and David that also includes some of the videos.
So yeah, thanks again to David and Alan. And Yeah. So, Tonya, thanks for joining us. I'll hand over to you. And
Hi, thank you. Can you hear me?
Yes, very clearly. Thank you.
Great. Yeah, hello everyone. My name is Tonya Christensen Johnston. I'm a textile designer and I work as a senior lecturer in textile design at the Swedish School of Textiles in Borås, Sweden. However, I'm in Gothenburg, where I live, so west coast of Sweden, which I am right now. Today I'm going to tell you about a piece of research that I conducted for the last couple of years. It's about development of a repeat system for surface pattern design and aims to introduce irregularities in a regular system, so to speak. I have this never-ending passion for pattern design, and patterns are kind of constantly in my focus. I see patterns everywhere. I can look out of the window and you will probably see a building which has a pattern of brickwork, and if it's a large building with many windows, these two will kind of form themselves into a pattern. Also, we plant in rows, we march in step, and somehow we systematize the reality with everyday patterns, which I guess all of us do. So there is something about the repetition that interests me a lot, and the huge possibilities that exist in the simplest pattern structure have always engaged me. So obviously, this was the basis for this project. In pattern design, pattern designers often try to hide the joints between the repeats to create this smooth, like endless look. For instance, the Liberty pattern to the left shows this classic synchronized mirrored repeat. On the other hand, Maya Luakari's Marimekko pattern kind of displays this half drop repeat, which is somehow nearly a standard in terms of repetition systems in textile design. But sometimes the joints are also meant to play a leading role, for instance, by placing the motifs boldly across the fabric's width, as seen in Elsa Chatin's pattern Tinnitus. It all depends on what kind of expression you're looking for. And a well-composed pattern usually has a pleasing rhythm to it, along with just enough complexity to keep things interesting. And the best patterns allure you. They make you think, notice details, and maybe even be puzzled about it. So great patterns require a second or maybe a third look. They reveal something new over time. They might be crisp and clear up close, but look totally different from afar. And that keeps them from feeling too predictable or boring. Experimenting with pattern joints is nothing new. And back in the days, both William Morris and Joseph Frank investigated pattern repeats, taking advantage and adapting also to the manufacturing methods that gave the technical frames, for instance, in textile print. In the pattern Miracle, as you can see here, Frank took repeat pattern design like one step further by combining step repeat and rotation. And he managed to achieve such intricate patterns that the repeat is hard to distinguish. And the more recent example should be the Timorous Beasties, which have this unconventional approach to repeat patterns, believing that a well-designed surface should flow smoothly and hide the joints between the repeats. That said, how the pattern is used usually depends on the surface and its purpose. For instance, here in their design Omni Drips, it's inspired by traditional damask patterns, having this modern twist. However, this wallpaper is printed railroad, as we can call it, meaning that the wallpaper is hung horizontally instead of this usually vertical direction. This layout makes it easier to adjust the design to fit the height of the wall more precisely. Sorry, I'm just going to shut up the sound a little bit. On this background, I am deeply fascinated by the emotional and spatial effects that come from repeating patterns. And I use that interest to explore the creative possibilities within simple repeat structures. And this curiosity is kind of the heart of my research, especially when it comes to rethinking and evolving traditional repeat methods. My main goal is to develop an alternative approach that introduces a sense of irregularity within otherwise irregular system. As a textile design teacher, I've noticed that students often stick to the block repeat or the step repeat, sometimes called, probably because it's familiar or feels easier to manage. So part of this work is also about expanding how we teach pattern design and using repeat rhythms as a tool to inspire new ways of creating pattern composition. Simply put, the multidirectional repetition means that the pattern can repeat in all directions, sideways, upside down, and vertically. The design is created so that each pattern unit connects in more ways than in traditional repeats. Where the units meet, there's a kind of passage or channel, like a flexible or tolerant area in the joints that allows the pattern's element to come together more closely and fluidly. So obviously I would like to show you a little bit of my work. My first try was just with humble pen and gridded paper. And I started off with very simple motif, these 4 eels or fish swimming freely. And to make sure that the pattern could repeat seamlessly in all directions, I had to be really precise with how the elements were placed. Any part of a shape that crossed the edge of the paper had to be exactly the same size and perfectly aligned on the opposite side. So I divided the eel's bodies, cut them in half, and placed each half in the center of each side of the paper. So the eels were 5 millimeters thick and carefully positioned then to match up when repeated. So when I completed the motif, I rotated and duplicated it 4 times to create this new, larger repeat unit, which I then put together in a greater pattern. So one of the main takeaways from this initial experiment was that the measuring points were key when positioning the pattern motifs. Another important insight, one that also confirmed my earlier thoughts, was about the joints as such, because this is where the real action happens, so to speak, where adaptation takes place. At the opposite, the middle area functions more like a free zone, where actually the motifs can exist on their own without being tied to the repeat structure. I carried on the experimentation with this narrow rectangular shape, similar to wallpaper. Continuing with the fish as a motif, and I designed them to be slightly universal. However, I gave some of them like eyes and a mouth just to insinuate a character and also to indicate upside down. By cutting the sketch into halves, it was possible to align the fish shapes with each other. And also the fixed dimension allowed the design to be step repeated vertically as well as in an upside down arrangement. And then I tried out every possible way in terms of repeating. And my goal was then, of course, to make the repeat in itself as unnoticeable as possible. In the central area of the repeat, meaning then away from the edges, the pattern motif can work independently of the joints. So in this particular example, it's the space between the fish that creates room for variation. And of course, I added colors just to make it easier to see. Then in this like background, white background, I added more fish, each one of them in different sizes, colors, and shapes. And all of a sudden, the repeat becomes almost impossible to spot, because the geometrical force somehow that a repeat provides is toned down in favor to a complete sense of freedom. So this is the multidirectional repeat at its best. Yes, as I mentioned, since I teach surface pattern design, I set out to explore how a multidirectional pattern repetition could be brought into teaching by running a workshop with textile design students. And the aim was to see how well they understood the concept and also how it influenced their design results. I gave them the same starting point as I did, like pen and gridded paper. And here you could see Ellen Johansson. She experimented with her pattern for wallpaper. And if you can see, you could keep an eye on the red crown. It's kind of cut in half, but it's the easiest element to see. And this, by changing how she places the designs, they will give you a certain different expression. I have another student, Christina Breitholtz. She was very intrigued by the potential of using multidirectional repeats, and she continued to investigate this in her degree work. She worked with the theme with storytelling and conversational patterns, using the narrative qualities in combination then with the multidirectional repeats. And she decided to use a triangular shape instead of the conventional square repeat format that is kind of always, we use always this format. And she placed the triangular shape put together in a hexagon, and she tried out different ways of placing the lines, meaning that she could experiment with different expressions. In her work then, she worked with visual layers in the pattern. She experimented with background, textures, and motifs. And simultaneously, obviously, then she tested the repeat to make sure that the distinction between the layers and the edges of the repeat were working. She reworked the unit, of course, then to hide the edges, and finally put it into a repeated pattern. And on the right-hand side, you can see the full pattern displayed using the multi-directional repeat system based on the triangular repeat unit. Breitholtz created a strong visual flow where all the individual elements come together seamlessly. She carefully studied how the motifs interacted in the repetition to achieve the right expression and rhythm. The pattern was built in layers, grapes, dancing footprints. She had a ball of yarn and a key, each with its own distinct expressive qualities through variations in opacity, color, and scale. And by using different repeat systems for each layer, she managed to create a kind of hidden repeat effect. The second pattern in her collection was called Pacifies Lover. And here you can see on the left side how the pattern may be repeated in several places depending on the expression. She printed her entire collection digitally, obviously, then on linen. So here you can see kind of result away from the computer. Yes. Conclusion then. The goal with the project was to develop an alternative approach that introduces irregularity in a regular system, making the most of the variation that a repetition can offer. A visual expression. The method, I don't claim it's to be entirely new or groundbreaking. However, the strength lies in how it challenges or sometimes even outmaneuvers a rigid repeat system. It's also a great way to bring movement into a pattern, to create vibrant surfaces or to design motifs with a striking visual impact. And the method works especially well when a pattern has multiple visual layers. For instance, in Breitholt's patterns, like a small repeating background pattern combined with a larger motif in the foreground. But above all, it's an exciting and enjoyable and great fun challenge for any textile designer. Yeah, and the format, like Breitholt's work demonstrates, alternative repeat formats can be used, such as geometric shapes like polygons, parallelograms, rhombuses, or even more irregular forms. Another potential direction is to incorporate digital tools like Blender or processing to explore coding-based pattern design. Develop research in pattern design. The main contribution of this work is the development of repeated pattern design, specifically how to bring more variety into the pattern by experimenting with different types of joints. It also offers deeper insight into the field of surface pattern design, shining a light on an area that's often overlooked in design research. So through this project, my aim is to raise the status of surface patterns and also to highlight the value of skilled pattern design and challenge the way patterns are perceived. The ability to create a seamless, well-crafted repeat is a core part of the textile design profession, and it should be recognized as a strong, essential, and highly specialized skill. The relevance. So why is this worth exploring further? While much of the existing textile design research focus on material innovation and responsive or transformative textiles, this work opens up new ways of thinking, specifically about surface pattern design, and more precisely about how we use pattern repeats. And my hope is that it will help move the field forward by emphasizing the value of designing surface patterns and the influence they have on both the creative process and the final outcome. Surface patterns shouldn't be underestimated. Their visual and emotional impact can be powerful, even magical, and they deserve more attention and appreciation within design research. Yeah, so the work isn't just about pattern techniques, it's about changing how we think about surface pattern design as a serious visual form of research that serves a central place in design education and discourse. Yeah, thank you for listening.
Thank you very much. Yes, thanks, Tonya. Beautiful examples there. I really love the repetition and the way that you're twisting those repetitions. Really, really fascinating. Kind of remind me of things like polyrhythm in music, and the kind of multi-dimensionality of timbre in sound. Have you had many sort of interdisciplinary discussions across the different domains to see if there are inspirations you could take from the?
Yeah, I mean, the design research conducted at the Swedish School of Textile is quite broad, and maybe also to connect to the previous presentation within rhythm and music. I have one colleague working with like sound
Mhm.
So yeah, definitely we're having discussions about. I mean, there are so many similarities between composition, both in music and patterns, and it's all about flow, harmony, rhythm. So yeah, for sure. I mean, as for now, I've been kind of more like into the visual part, but definitely I'm open to I don't know, embrace other fields as well, since the connection points are quite close.
Yeah, I suppose surface pattern design, we do think of it as two-dimensional often, but here I feel like you're manipulating more than 2 dimensions, and so the outcome just seems so rich. Yeah, fascinating. Are there questions in Berlin or online? Let me check. We are a little over time, but could have time for one if there is one. No, it looks like that's it. So yeah, thank you very much again, Tonya, and look forward to where you take the work next.
Thank you.
Oh, thank you. Okay, thanks for the applause there. Berlin, always nice to feel the warmth of that. So while I configure things, I'll welcome Caddy back to Algorithmic Pattern, who presented some very nice work 2 years ago at the Salon. So here's your slides. So yeah, I'll pass it over to you, Caddy. Good to see you.
Yes, thank you. I'm Kadi from Balazs University of Applied Sciences, and I present you a video of technique multi-weave. I will switch between building machine and craft technique and art and design, and I have been developing it since 2016. And it started from a very nice prototype we built in 2016. And the idea of hackathons just struck me that I can really share my ideas and get feedback from people from other specialties. And it really changed my life and changed how I think about textile developments. So the idea of the system is that you have pre-supported warp loops, and you guide weft around those warp loops, and afterwards you get a structure that is that might be of natural materials, no adhesives or no glue needed, and also the inspiring 3D structures that 3D printing has showed us is they are accessible to textile artists also. So the idea is that we have the field of warp loops, and then we create a mass of layers of weft, and then to end the structure, we connect the warp loops to each other. But although the development of machines was very inspiring and very cool, then I noticed that as we are art university, we don't have exactly resources for machine building. So I made a turn and started to develop this as a craft technique. So here you see some basic tools that we developed for this. And this process now is how I end the warp loops connect with each other. And here is how we remove the temporary supports from the textile structure. And the beauty of it is that the weft placement is still done the same way as in 3D printers, that you put the material between and around warp supports layer by layer. So in terms of what can be done differently than in normal weaving, you can cross different sections of warps and grow forms in different directions. And this method we use with first-year students who don't know yet anything about text or weaving, and they from the start must think about these 3D options. And all this consists of warp and weft, so that is why we call it weaving. And now I present works of Marilyn Piirsalu, who has been a great support from the beginning. She's a visual artist, and started to make multi-weave structures out of packaging material, and created extremely nice works. So here you see that even from the very like cheap material, it's possible to create interesting multi-weave structures. And the point of this video is to show how the structure like acts when you move it, and what kind of character it has. This is her work from an exhibition in 2022 we had in Tartu, Gallery Pallas, and it was presented together with the tools that it had been made. And I'm very happy because this is the work that now our Museum of Applied Art and Design has brought in its collection. So multi-weave is already in the museum. But during this process, the crucial element is that you are not the only crazy inventor, but you get students who are inspired by the ideas. And the exhibition grown back in 2022. I invited my friends from Sweden and Latvia and Finland to make student projects. And this exhibition, as it was COVID time, we just sent everybody the tools and also the video instructions, and students from every country developed their own like versions of this system. And also we encourage people to build their own tools, and we ended up in tools that weren't necessarily from cardboard or plywood, but also we could use barbecue sticks. And Emilia from Sweden, she continued to work with this system, and I saw that she had exhibition with very interesting multi-weave developments. So this is the great joy when I see that people go on with developing it, because it's like an open source technique. And so what is different in weaving and multi-weaving? Here I schematically show how the different positioning of warp rows affects the overall object. And with first-year students, we also do a task. You must join second join multi-weave structures with some second hand garments. So this is again a good like task for combining and building 3D weavings on top of something. So Miriam Hemström from Sweden, she enlarged the tool and made works of that. And Svea Tisell is one of my favorite persons, because she's now making a collection of multi-weave furniture out of only strings, and here she shows how she is weaving a chair using 2.5 kilometers of string, and afterwards the rigid supports are moved, and it's then monomaterial object. And her Instagram feed shows that she has also developed all kinds of other pieces of furniture. So this is one of my own projects that we are also always searching for, can it be used for geotextile? So this is from linen felt structure, and this piece is now in one exhibition until the end of October. And I was very attracted to the idea that when you think of the mathematical problem Knight's Tour, where you have to cover with the moves of chess figure knight all the fields, so that it visits every point only, every square only once. And I used this same method, so I made the sequence of moves according to Knight Tour. And here I'm like yesterday I wanted to make this version that, as in Knight Tour system, the figure moves between black and white squares, and I make the rounds then clockwise and counterclockwise. So this is this is a thing I think I will develop further also. So as I said, the first year students also got inspired by multi-weaving. With they had to connect with second-hand shirts, and you see all kinds of variations how you play with color, you play with structure and chaos, the combination of structure floating out of the form, and how it adds to the visual impact of the outfit. So I asked them to do a small video, and so this is from our school. So also weaving without necessarily being rectangular is what you see here, and also taking a ready-made like object and add some structure and functionality, like here. And, so these were the authors of the works you just saw, but I still haven't given up hope that someday we have also the machine. And my colleague from the university, Rasmus Eist, who works at the sculpture department, said that, okay, let's make a multi-weaving machine out of laser cutter. So we printed a set that holds the weft guiders, and made this drawing then in Adobe Illustrator, and so we could make the laser cutter to weave, multi-weave. And this is one performance our now fourth-year students made. Also used this multi-watt guiding system, and now, although it was like meant only like an interior textile or something, then Christina here at once started to wear it. And these were the authors of this video you saw, and I'm very thankful to our university that keeps on supporting me and ask us about multi-weave. We are happy to cooperate. Thank you.
Wonderful, thank you so much. Yeah, please do ask questions in the chat. Yeah, really inspiring, and yeah, you must really enjoy seeing what your students do. And I love the idea that this was their introduction to weaving.
Yes.
It's quite an unusual view of weaving practice. Do you feel that seeing them look at multi-weave with fresh eyes also helps you look at multi-weaving with fresh eyes and see things through their eyes?
Yes, of course. It has been from the beginning that that the most important thing is when well, you do something like invent, you push it and you get like strange looks and nobody believes you. But then you have some persons who say, wow, I want to work with it. And then this also like changed my perspective to all the process. So now I'm already very confident with it. And on Thursday, we were presenting this on New York Textile Month. And the organizer, Lelia, said that I know every textile technique and I have never seen something like this. So yes, I'm very proud of what people are doing with it, and I'm especially proud that we all we try to do it as an open source thing, so that we share the method on our courses, and we say to people that when you publish on Instagram, please use multi-weave hashtag, and I'm glad that then we see that people from New Zealand or Belgium or other parts of the world are using it and developing.
Wonderful, yeah, great. Yeah, we'll have to try and organise a multi-weave workshop here in Sheffield for sure. And you also mentioned at the end there was a performance. Could you say a little bit more about that? Were they textile students performing with multi-weave, or were they? Yeah.
Yes, this idea was that I wanted to demonstrate how quickly you can weave when you put multiple wefts at a time. And then we made a plan that usually the structure is horizontally, but what we for video reasons we put it on the wall. And afterwards, students said that it wasn't a very good idea because their hands get really tired. But we managed to get quite a nice performance for. It was like a video event,
nice.
And we used we use a lot of material from a factory in Tartu that is making shoelaces, and they are very supportive to us. So we get a lot of material to experiment with, and that's good, because with multi-weave we want the structures to be like really visible and very like stressed. So so we need a lot of this kind of string.
Yes, of course. So are there any other questions around the world or in the chat? No, I think we are done. So yeah, thanks again, Caddy. We're heading into a break, but actually we have a performance. Let me just get that together. So this is from MOT4I. I shall bring it up here, and it's called Procedural Pulse. So let's have a listen to this. Oh, I just want to make sure I've got the right version. Yeah, this one. Great, thanks MOT4I for that banging intervention. We'll be back in about 25 minutes for 2 more presentations from Sol Saratia and Stephanie Pan. Nearly there. See you in a bit.
Brilliant.
So, Federico?
Yeah.
You have the mic. It's on your left.
Yes. Hello.
Hi.
Greetings.
Hi. Where
I shouldn't unmute my mic, right? Or I am.
you've got a mic?
Talk to the
Hola. Oi.
Yeah.
Yeah,
Yeah.
I'm here.
But stay close to the mic.
Close.
Yeah.
Bueno. I'm a little bit sick.
We're setting all up, and we're actually nearly done.
Cool. So the other speaker the second speaker will be Stephanie Pan. Stephanie, I don't see you in the studio link, but I see you in the chat. So if you'd like to join the studio link, then we can quickly test you, or we could do that after Sol's talk. Aha.
I needed. I'm again.
Did you wanted to share your screen?
Yeah, and I had to give permissions. So
Okay.
I just dropped, but no.
Oh, right.
Hi, Stephanie.
Hello. Sorry.
It's all right. We're just setting up now.
Okay.
Did you want to quickly test your slides? Or?
Yeah, I'm going to upload that now.
Cool.
Let's see.
Does it work?
Oh, yeah.
You're good there? Right. And you
I'm
that's
sure.
Sol's slides.
I'm there. Yay.
Great. And the sound you tested.
And then should I upload the video file that I might play? We'll see.
There's a
Yeah, sure.
So there's 25
okay,
minutes for each presenter.
So
Yes. What do you think? Oh. Okay.
Ah, yes, I see.
Something's uploading. Yeah. Oh, yeah.
So this is a video, is it?
Yeah, there's a video of like the app that's been developed for developing textures.
Nice.
It's 2 minutes long, so I'm not sure I'll play the whole thing or anything, but just to give an idea.
Yeah. Okay, let's not give the game away. So I'll pause that. That looks good. And
how do I test this?
and right, I see.
Oh, there. Yes.
Yeah, I have to add it to the stage, but then you have control over it once I've done that. Looks great.
Okay.
I think you'll just need to prompt me when you want me to play the video.
Yeah.
I'm not sure if you can. I think I have the admin permissions to have things, but
okay.
Okay.
But the
great.
slides I'll be able to move myself.
That's right. Yeah.
Okay.
Yeah. Should make sense. Brilliant. Okay, so I'll put you back in the. I'll take you off the stage and add Berlin back. So it's going to present from there, and then
super.
Introduce you after. Yeah. Nice to see you.
Okay. Yes. See you soon.
let's do super collider test. Are we ready? I'm worried. Ahora? I think it's okay.
That sounds great on the stream. If that's
That's
supposed to be a
good.
sine wave, it came through very sine wavy.
Yeah. Okay. So that worked, and your voice also is being heard.
Can I test title? Because I don't know why this is louder sometimes.
Okay,
Maybe
and then
because
we
I
do-
was increasing the amplitude. That has sense. Oh. No. What happened?
Sounds good here.
Bueno.
Okay.
Sounds good here too.
We can perhaps start. What do you think?
We are starting.
Yeah, Alex, are we ready?
Yeah, take it away, Berlin.
All right. So let's start.
Okay.
With Sol.
Hi, everyone. I will be talking about sine waves, P sine waves, a little bit of introductions. I'm a programmer. I work as a full stack programmer. I code in the day, code in the night. I love computers. I have a background in math, and once in a while I come with wondering stuff like what if things. So a little bit to motivate this talk. I was thinking a lot on what are like sine waves in different metric spaces, or what if we like change them? Because sometimes like observing the same object in a different way, you can get more insights. So I want to share with you my process of approaching this whenever I have a what if situation in my head, how I actually coded. I'm also sharing code. I did a GitHub repository, and hopefully a little bit of a demo and have fun. So to start, I think most of us are familiar with what sine waves are, but I like introducing them as circular functions. As well, I will say, like, imagine we are walking at a constant speed, distance 1 through the origin or through another point, and then we track like the y coordinate of that distance that you have been walking in the like the arc length. Then that is a sine. So basically, you walk along the path of all the points distance once from the origin, and you get the height or the y coordinate. And well, this actually I will mention a lot the unit circle, and the distance is something that we are assuming mostly all the time. I think when we learn math, like distance is something that it's there, and we never really question or think about it. So if we want to measure like 2 points, A, B, and we are like just taking like the blue line, yeah, that's how we measured. But we need like a referential context. We need a space, and in this space we can like actually describe the positions of the points. And once we describe the positions of the points, we have like that formula that it's really like, thank you Pythagoras for giving that. But once we have the distance, it's like, okay, let's build all our geometry notion on top of this. And if we kind of generalize this notion of distance and we swap like the 2 by p, then we have infinite numbers of distances, like with p in a positive range. And this introduced like what a p norm is and LP spaces that are basically all the spaces, which here I put the unit circles. I don't know if you see them, but the unit circles change according to the p-value. So then the circle in p equals 1 would be like a diamond shape. The circle in the infinite or in a very high value would be similar to a square. And with this idea in mind, I was like, well, actually with less than 1, we don't have norms, but it's still fun to play. And with this in mind, I was thinking the sine wave, like, okay, I am like walking through these different unit circles. And actually, if you do it, like you will walk, like if you start with p equals 1 is the triangle shape, like triangle sound. If you like increase, it's like a square wave. So then you have this smooth interpolation between all sine waves, which is very fun. And I'll do a little demo. I'm really not tracking time, so let me know if I am. I will do first visual demo because I'm a visual person. Mostly. I'm not sure what I am actually, but yes, I don't know if you are familiar with shaders, but if you want to like draw, let's do like this. Circle, we use these sine distant functions. And this is not what is wrong. Oh yeah, no we are. Syntax error. Yes, parentheses. Yes, here. So this is the I'm using the function length, which is the Euclidean length that we first saw, and then here I define like the p length, which is the generalization of the length, and we see that if we change here values, you can go from diamonds to squares to shapes in between. We can use like a little bit of motion. And we can also not just having like shapes, different shapes, but change motion. So if you are familiar with how to parameterize a circle, yes, we just saw it. This, yeah, and I could also let's a little bit like that. And if instead of using this, we divide it by the p length. And here I will, yeah, let's do like this. And yep. Maybe I should have coded this before. And here, let's say, yes, and I will add a little bit of feedback, and I will leave it as a circle so we can see. Yes, a circle a little bit bigger. So here, if like I use the value 2, again, we can go a little bit faster, will be the motion of a circle. And again, we can have like motion of a diamond shape or a motion of a square thing. So now that we have, like, at least you get some concept of what this is, I want to share with you an experiment I built in Super Collider. So first let's do like this. And hopefully will be sound and visuals at the same time if things don't crash. So I tested and this was working, so we can play it again. And here, I will just get, well, maybe I can try everything. I want to map now, like frequencies to the visual part. I'm not sure if this is gonna be, so now we have like a frequency, a major third, perfect fifth, and octave. And if with that, I don't know where my controllers are. Yeah, like now I will put the fundamental like in a square. Like we can change. Where is my controller? I think you got the idea. It's like playing with different like shapes of the sine wave, which was like a fun experiment. And with the trajectories, you can see, I actually also find it very nice to have like this visual and audio way of mapping, because another example could be introducing a shape as a Ray Martin world. I don't know if you see my screen. Is it bright enough? Yeah. And let me add a little bit of color, and yeah, and things you can control again with these things, like the shapes. I don't know if you ever coded these things like sine distant functions, like doing squares and circles. It's not that easy to interpolate, and now we have everything into like one function, which is very nice. So you can leave cubes, and then we could also control like the camera movement. Like imagine the camera, we can move it like circles, or we can like change it. So this, I think, it's receiving the second one. I should really do something with these sliders. Yeah, if like we do it like that, it's like it's doing the shape that was. I think we can see it here. And I will. If it's smaller than one. Okay. Yeah, look at the blue one thingy. So the blue one will be moving the camera, and the red one is defining the shape in this word. So the camera is being like that. And from there, you can like, it's really fun. Like, I don't know, there's a lot of explorations. I think we are done with this sine wave, which can be very relaxing also. I will free the sound. Okay. And I also did, this is for like title users, which I guess it's mainly more people. I defined the P sign, I called it, and I'm really not a title person yet, but I tried to do some examples, and I think it's fun. Like, yeah, this is very slow. This is basically iterating like the p-value in between 0.5, 1, it's like the diamond shape, 2 is a circle, and this is a square. So it's basically listening how they look different. And then you can like create stuff. I didn't do something very nice about this. To show actually the function, like the... I think like in the first channel you can see how it goes like from circles to triangles to whatever. And yeah, I think this was, I don't know how to uncomment. Ah, this is not my editor. Like this. Yeah, I don't know. You can play. But basically, I wanted to like share these things. And going back, I think I'm okay with time. It was supposed to be short. Yeah, basically how I define the sine function, and this is something that we can talk. I'm just mapping like the sine function that we have in our Euclidean world into the LP units in different units, and this is the demo of what I exactly did. But and yes, and then what, like sound, you can have these smooth interpolations between like waves. Graphics, you can use these values of P in a lot of different places, shapes or motion, and it's very nice to be able like to explore both worlds at the same time. So I did this. I didn't need this backup slide. I had it just in case. I also have this just in case, but no, the supercollider was with me. So you can check the code, or you can write me an email, and I'm really happy to listen to feedback or questions or whatever you have. Yay.
That was very nice. Thanks. Are there any questions?
You're not reading the chat.
Chat, let's see.
Yeah, I really enjoyed that. It's I guess as computer programmers, we do kind of think in terms of discrete things and not all the possibilities between those discrete elements. Recently, I've been getting really into Malcolm Braff's work on Groove, how instead of just dealing with discrete sequences, you can morph between sequences and see the little things in between. And it's just really nice seeing the same idea applied on multiple levels of abstraction. So yeah, thanks very much. I don't have a particular question, but yeah, it'd be nice to explore how to pattern these different things more further in Tidal.
Yeah. Like shift patterns around. With
Okay, we have a question coming in from Barcelona.
Nice. Hola.
Hello, Sol. Can you hear me?
Sí, hola, Iván. Hi.
Oh. Sorry, just a sec. I was muted. Yes, perfect. I don't know if you have create some of these graphics because you are iterating the p-value and you are jumping between a specific grid. And as a mathematician, I probably you have thought into finding probably phase transitions or special behaviors according to the p-value you select. Have you find any of these, or it is basically a continuous pattern or a continuous shape going from completely sinusoidal to more triangular? Or is there any, have you find any funny behaviors happening in between of how they behave graphically?
I haven't found any like any pattern, but I've been in a lot of rabbit holes, which were fun. Like maybe sound-wise, like you really notice like triangles from like harmonics and from squares. So when you are doing like the interpolation, you kind of like it's nice, and if you like do it with a lot of frequency, then you get like inferent, like weird sounds. I had like a really big rabbit hole with the concept of pi. I can bring it up here, and understanding actually like how like pi can have like different values in these different worlds. And that led me to think more of like the properties, of these waves. But I didn't have like any idea on that yet. I'm also thinking like what I'm doing, it's not completely correct. Like I would like to define like, maybe it is, but I'm thinking like I'm just taking our definition, like how the computer computes sine functions that is in Euclidean. Maybe if someone knows the answer, then let me know. If I want to define like in a LP space, then I should redefine the sine function or compute it from scratch. You know what I mean? And I've been like thinking a lot about that, if that affects like speed and time. I don't know if you saw, but these shapes that were like smaller than a diamond, like I don't know what is the name. Those are like affecting also time, and you also can listen to that. So I'm not sure if that it's okay or it's just like a side effect. But those were like the things I've been like exploring, and yeah, I'm happy like I hope people like play around with that, and then we can think about fun stuff. And actually, all of this started in Barcelona in the ICLC. Like my friend was like, "Oh wow, what if?"
Yes, we remember.
Yeah.
Cool stuff. So unless there's further question, we might have time for one more. I think we might be a bit tired at the end of the day for lots of questions, but thanks so much for your presentation, Sol.
Thank you.
Every
time I do like this, you don't see me, but I am like moving my leg.
Okay. Lovely stuff. So we have one more presentation. It's been a long couple of weeks. Let me make sure the stage is set for Stephanie. Hi.
Can you hear me?
I can very well, yes.
Oh dear. Okay, great.
Well, in a good way. I mean, you're coming through
Yes.
very clear. So, and we also have a video queued for later. I'm just going to make sure that's okay. Yeah, that's all good. But that's a foreshadowing of the presentation to come. So I'll hide that again. Okay, yes, take it away, Stephanie.
All right, great. Thank you. Thank you so much for this opportunity. I'm really excited to share this project with you. My name is Stephanie Pan. I am a freelance artist working mainly actually in sound. So I'm a composer and a voice artist, performance artist, interdisciplinary maker, and textile artist. And together with my duo partner, Stelios Manusakis, I co-founded and artistic co-direct Stichting Modules, or in English, Modulus Foundation, which is an artist-run production house. And we operate at the intersection of art and technology research. We really work in a way sort of beyond discipline. We're really interested in sort of answering or asking big questions and using whatever tools are necessary for that. And today I'd like to talk about algorithmic knitting design, which is a project I started in 2020, where I develop knittable or like knitwear patterns for hand knitters that integrate algorithmic computing into their designs. And to do that, I've been working with several people, with Stelios Manusakis, who's a composer, an interdisciplinary artist, a researcher, composer, software developer, Jan Truchler van Valkenstein, the three of us are based in The Hague, and computational architect Wei-Hao Wang, who is based in between like Japan, Taiwan, and UK, and he's the founder of Sawara Architects. So the project, I started in 2020. There are currently 10 published patterns, and I try to publish about 3 to 4 patterns a year. And I sort of consider this a new branch of my practice. In a past life, I did a bachelor's at UC Berkeley with a double major in applied mathematics and music. So that's sort of been in my back pocket. Otherwise, I basically operate in the art sector. Through the project, I use algorithms to populate the surface, let's say, of knit wear, to create the textures. So this is like knit and purl in knitting, which are the two most basic stitches we have, or color work. Let me see, where's my color work? This one, which is a cowl. And what else do we have? Intarsia, which is another form of color work where you work in blocks of color. So this is Intarsia. So it's all being knit together in one piece rather than sort of knit separately and then sewn together afterwards. A new version of Marlisle, which I have developed for this pattern, which is about to come out, for knitters, it's a way of working color work where you can work back and forth because you carry the colors together instead of having to carry what is called floats. In the back, this is like a color work sock. This is what it looks like on the back side. You have to sort of negotiate the two colors at the same time. So with this project, I'm sort of looking to posit knitting and other handicrafts as a form of applied mathematics and applied science, and that mainly from the perspective of the knitter. So from the crafter themselves, what happens if we start to think of ourselves as scientists or mathematicians, and like how does that sort of jog the way we think about the craft? And it related to that, sort of taking a major step in updating the aesthetics and the sensibilities and the possibilities of hand knitting, like specifically knitwear made manually. And the third is to sort of democratize the notion of high art by publishing artistic blueprints. So I'm really, in a way, very uninterested in fabrication myself. I really like the idea of publishing patterns that people can access and can replicate themselves in whatever way or means they have possible. So once you have the blueprint, you decide what yarn you want to use, what needles, what colors you want, what materials you want, depending on what your aesthetics, possibilities, all of these things are. So where's my, do I have some, I'm trying to, how do I do this? Yes, there. So this is one of the designs. So I was going to tell a little bit about the background, my personal background, about how I came to the project. So I am a crafter by nature. I've been sewing since I was in my teens and designing clothing. I was crocheting as a child. I'm an origamist. I've made shoes. So I'm really like creating things with my hands is really important to me. I came to knitting like fairly late in the way, in my 30s, once I'd sort of hit an aesthetic wall with crochet, where I just felt like it felt very outdated to me, and it was really hard for me to create anything that I didn't feel like reflected my aesthetics. And I started getting into knitting, but I was very struck at a certain point when I was trying to look for patterns that I could knit that sort of balanced my need for pretty complex knitting as an activity with what I actually wanted to wear. So when I had, you know, you could have a very beautiful basic sweater, but I would just die of boredom because all you did was knit one stitch. And so I sort of found this very frustrating. And that was the sort of initial balance. And then eventually I started designing patterns for myself. And I would read these patterns to studies every once in a while, or patterns from other people, because I found they sounded like computer code to me. And so that sort of initial parallel that we sort of came across together really launched the idea for algorithmic design. So within the realm of knitting, there have been some projects that are sort of dealing with algorithms in knitwear design. We're right now particularly focused in cellular automata because it translates pretty inherently to certain techniques in knitting. There's Fabienne Serrière, or Knityak, who was working with cellular automata. Locally here in the Netherlands, there's Sebastian Cox, also known as Monobrow, who fabricates glitchware. And in all of these cases, it's all fully fabricated. There are some experiments in the last 25 years that I know of in hand knitting patterns. Debbie New was possibly the first designer to use a cellular automata. Nora Gon, who's a pretty famous designer, has done one pattern that I know of. And Lana Holden has done some things, but it's been pretty thinly spread over the years. So I wanted to really sort of try and expand the challenges that we are willing to take on as crafters through this project. So I wanted to share with you a little bit the process of how we do that at Algorithmic Knitting Design. It's been through a couple different iterations at this point. The first thing I do is really think about design. And in that respect, I'm really inspired by Japanese and Belgian minimalism. So I'm really interested in form and shape and drape. So how shapes fall onto bodies, less than actual, like, more traditional construction of top-down sweaters or raglan sleeves, these sort of traditional constructions of knitwear. And then I really love the glitch of or the chaotic nature of digital aesthetics. So I wanted to sort of bring these things together, and that's sort of the aesthetics of how I design. So the first thing I do is decide what the object is going to be and what the construction is. So this is the schematics for Soliton's sweater, which is the first sweater that I designed. And on the left, you see how it's constructed. So it's knit starting from the bottom horizontally, and it's effectively knit on the bias. So it's sort of tilted 45 degrees, and once the whole thing is knit, and the neckline is sort of knit in as you go along. So it's knit as a single piece, turned 45 degrees, and then attached diagonally at the bottom. So that is the world, let's say. And then what happens there is after that I decide on the yarn and the needle size, and I knit a swatch to determine the gauge. And that is sort of how we calibrate in knitting. So it's a way to sort of know that we're all sort of speaking the same language. And if we're not, if someone's gauge is different from my gauge from a pattern, how they can adjust the pattern in order to still replicate design more or less. So that happens. And once we've got that, then I would go into what is now the Knitting Factory app. So if this started with Stelios, it was based on, where is it now? Mirc Wojciechowicz Cellular Automata Simulator, MCell, was replaced very quickly after that by Stelios's interpretation of that or implementation of that in Super Collider. And that has since been ported to an app by Jan called Knitting Factory. So we could maybe look at that very quickly. The video. So this is where we're sort of at. This sort of now allows me to design a bit more autonomously, so I don't have to sit Stelios down every single time. And it's based off the workflow we sort of developed. So once I have determined the gauge, I know how many stitches and how many rows I need to create the piece of fabric I need to knit. And then I input that into the app. So the width would be how many stitches I want. The height is how many rows I want. And then you can go in and populate which cellular automata you want to use. And we like to leave a little bit of chance in it. So you can determine the initial seed. So how many ones there are. And sort of randomly placed, and then a range of the minimum and maximum rows that something can happen, whether the selection of cellular automata is randomized or if you want it in a specific order. So it has a lot of possibilities for playing with. After that, we like run the software a bunch of times and save, I don't know, like it's starting to get up to like upwards of like 40 outputs that I can then play with and spend some time with and determine how I can interpret them. So we output a PNG file that has exactly the number of cells, let's say. So every pixel equals one stitch. And I take that PNG and I drop it into a web-based app called Stitch Fiddle, which has been developed for knitters, which can translate images into charts. So I use that like black and white PNG from Knitting Factory to drop it in Stitch Fiddle, match gauge basically, and then start working with it. So for things like Knit and Purl and Fair Isle color work, it's sort of one-to-one. It's pretty easy to deal with. I think we can stop there. Yeah, let me see where we're at here. If I go back to the slide. And sort of translate it. So this is the Soliton sweater again. So the image before was the PNG of a single cellular automata that I used for that first design. And this is sort of how it gets translated into Knit and Purl with some shaping in the corners to create the waistline and the wrists, the cuff. And this is what the object becomes. So in order to then translate from that place to this, I knit a sample, and this takes anywhere from 1 to 2 months, depending on what size the project is. And if that goes well, I write it up, size it, which can take quite some time, and then ask a bunch of test knitters who are effectively sort of beta testers who get advanced access to the pattern, and they give feedback on what their experience is. After that, we take photos and then publish the pattern online, and it becomes available for any knitter who wants it. They're sold on Ravelry or via the website. And so that was Solitons. This is another one I just wanted to talk a little bit about. So the project is not particularly dogmatic about sort of algorithmic purity. I'm really interested from a sort of aesthetic perspective. So I've started working more with combining different outputs where it suits me, interpreting them in ways that work better for knitting or for interest. So you'll see here on the left is the black and white are the 2 PNGs or 2 different outputs, which I basically combined. So the white areas are the places I basically took for this design. And in the second black and white model, you'll see that I also added some texture. For example, like I added some lace just to add some interest. So it wasn't just this sort of plain solid surface. And that's, the sort of outcome of it. Where am I at? Oh, yes. So some thoughts on the process. What's really interesting is how, looking at what cellular automata work well for different techniques. So things that are pretty chaotic, can work really well for color work because that's sort of the clearest way. Things like knit and purl designs, this one, are much subtler, let's say. So they don't sort of show patterns as clearly. So there are certain things that have lots of diagonal lines, things like this work better for knit and purls. And the system, the workflow starts to break down when we start to get into more complex knitting techniques that don't translate one-to-one. So I've been working with Weihao on cable textures. And so where the workflow really breaks down is in lace and cables. And they have sort of similar challenges. One being that the commands are just much greater in number, or like cables just don't. I haven't found a way to translate cellular automata and cabling. Like it's just a totally different language in a way. Lace, you can almost do it, but the problem is that there's all this interdependency in commands. So like if you insert a hole in lace, basically you increase the number of stitches. So somewhere along that row, you have to decrease the number of stitches. So there's a sort of interdependency between commands that I haven't quite worked out a way to deal with yet. We're working with Stelios on L systems now as a sort of new step, but it still has sort of similar challenges. And one of the biggest challenges is that the charts that are output for lace and cable are very much not representative of what the output will be. So you can see here a little bit with the cable software that Weihao's been developing. The left is sort of a way of visualizing cables, and then having a sort of more closely related visual output on the right to be able to visually place cables, and how we can sort of work forward with that. Lace, both of them are just like the charts are generally very cryptic. So that's some of the challenges we're sort of looking at in the future, sort of working towards. I'm looking at eventually maybe doing a residency in TU Eindhoven with Christian Andersen, where they have a knitterate to look at things like prototyping, which is a very, very time-consuming process when you're totally focused on hand knitting. So yeah, I'm like running a little bit over time, so I think I'm going to stop now. But I just wanted to sort of conclude by saying I think what I'm really interested in is sort of offering this question of like, if we as knitters see ourselves as scientists and mathematicians, what does it do to the way we approach the craft? So that's it. This is all the collaborators in the group.
Wonderful. Thank you very much, Stephanie. Always good to rely on Berlin for some clapping. Yeah, lovely presentation. Great that you're going to visit Christina in her lovely lab in TU.
Yeah, she's great.
So there's a couple of questions popping up in the chat. Eliane has one that was going through my mind as well. Like, this is a hand knitting project, and if the hand knitters are following charts, then what's the experience like for them? Is it really difficult, or do they find themselves following the algorithm to some extent?
So I think it's really like we've developed some really cool hacks basically to like color coding charts. So if you add different colored stitch markers, like every 10 or 20 stitches, and then add a vertical line in the chart, because the charts are enormous. The charts can get to like 300 stitches in a row and 400 rows for the really large pieces. It works really well actually for keeping track of where you are. So like if you have, we use stitch markers. I use stitch markers in a very different way. So I use stitch markers just to like mark places in charts where they're traditionally maybe a bit more used for repetitions or this kind of thing. So when you see you're coming up at red, so you only really have to keep count for like 20 stitches or 10 stitches, depending on how you want to mark them. I have gotten a little bit better about dealing with error myself. Like I'm pretty like, I want them to be right, but sometimes with these chaotic patterns, you're like, nobody's ever going to see this. So I just sort of let go of correcting everything. But and the other thing with rows is like I like printing out charts. I recommend that people print out the charts and sort of glue them together, and then I tend to use a highlighter to mark off knit rows, and I've gotten to the point where I can sort of mark off one every 10 rows or something, and I'm pretty good about keeping things. And I'm like I'm a good knitter, but I'm not. There are many knitters who are much better than me, so they do really well. They burn through these things sometimes, and I think that's really fun. That like just offering knitters new challenges that really lean into inherent capacities they already have. Like they're really capable of doing all of these things. So it's still like a little bit of a niche audience, let's say. I'll admit there's a lot of people who are more sort of TV knitters and don't want to do this stuff, but I know I'm not alone. There's like quite a few people who like having a fun challenge.
Cool. So Madeline says that they've been craving this sort of system for about a decade without knowing where to start, and just asks a question: is the Knitting Factory available for Android?
So it's not been like publicly deployed yet. We're still sort of testing things, and we're also sort of figuring out how that app is going to exist. You can, like, the thing is that you can actually play with Yota Morimoto has made a port of the M-Cell from Wojciechowski. What's his last name? I always forget his last name. Wojciech. So those things are readily available, and that app is basically a version of those open source simulators. So the work of designing is still very manual. So all of the shaping and all of those things are not in that app yet. I don't know if they'll ever be, in a way. Like, I think that app was sort of developed for me to not have to get studies to sit down every time I wanted to make a design.
Okay. Right, so Amy has a question. Have you ever worked with existing traditional patterns and made adaptations from there? They're interesting questions of artistic appropriation when working with existing patterns, especially traditional ones. What's your take, or does it not matter?
I'm actually not focused on that at all, because I find the use in knitting tends to be very repetitive, and it's part of what I really don't that doesn't like appeal to me. I really love asymmetry and chaos, and it was one of my challenges. Like I really love like a Fair Isle top yoke. If you're a knitter, like a Fair Isle top yoke, top down yoke sweater is very appealing as a knitting process. But I feel like a circus lion when I make one of these things, because it just sort of like these things that sort of repeat in frame. I really don't. It doesn't appeal to me. So I sort of have sort of eschewed the notion of traditional patterns, I think, just because they don't suit me aesthetically, let's say.
Fair. And Elian has a follow-on suggesting the benefit of using algorithms in hand making is using the algorithms when hand making. I suppose something here about the agency of the knitter. So here it seems the design process comes before the knitting. Can you see ways in which that design process could be brought into the knitting itself?
Yeah, I mean, I think part of what I really want to, where my focus has been, is that I want knitters to be able to surprise themselves with these sort of chaotic patterns without having to know how to program.
Mm-hmm.
So just more really from a sort of crafting perspective of just being allowed to just like be told what to do and then and coming up with it. And knitters, I think crafters, like they really run the spectrum of like, I want to know exactly what I'm going to do. I want to know exactly what it's going to look like. So you have knitters who want to get a pattern. They want to get the exact same yarn, the exact same color, and they want to know what they're going to get. And other ones who are very open to just sort of changing things how they like and sort of loosely interpreting your pattern. But I think for me is really, like personally, as someone who also like totally doesn't code, it's like always been a little bit too abstract for me, despite a sort of love for numbers. I kind of liked just having people be able to read charts and being able to reproduce something without having to worry about whether or not people are able to code. Yes. Or like interpret algorithms.
Mm-hmm. So I think we're coming near the end, unless there's a short question from one of the hubs in Barcelona, Linz.
Yeah. I have a short question, actually.
Okay.
Thanks. I was checking out your website. And I don't want to sound lazy, but I was wondering if one could buy the finished pieces anywhere.
We have just started that. So that's actually a really new, I actually announced it yesterday on my newsletter. It is possible. You'd have to get in touch. I have a professional knitter that I'm working with who can fabricate. That's something we want to try working now, that it's total like, there's a very limited number of orders, of course, at a time, but it's possible to have one prefabricated now.
Great, thank you.
Wonderful. So thanks again, Stephanie, for that lovely presentation.
Yes, thank you so much. And thank you, everyone, for all the speakers and the conference. It was great.
Yeah, indeed. Thanks to everyone. So that concludes Algorithmic Pattern 2025, apart from one stray workshop coming up in a couple of weeks. You can check the website for that. But yeah, it's been wonderful. Thanks to all the organizers or the speakers or the artists involved over the last couple of weeks. It's been a real roller coaster. Thanks to the hubs today. Oh, and we've got
Alex.
Yep.
Alex. Yeah, I just want to say that I wanted to give some special thanks to Fang Tsai and Iman Safavi, which are the people that made all the video and audio happen here. So, Iman is here, and Fang is actually up there. Maybe I can, yeah. there. And they did a fantastic job here to setting everything and accommodating all the requirements of the presenters when it came to using their own laptop, sharing audio, not sharing audio, not using their own laptops, and everything worked seamlessly, and we had a great time here. So yeah, I just wanted to acknowledge their excellent work and also thank the New Practice Studio for hosting us. And also, by the way, Fang and Eman are part of a group that is called Inküle, which in German stands for Innovation für künstlerische Lehre, which is innovation for artistic teaching. And they do lots of these very interesting things with technologies for the arts. So thanks, guys. This time, applause for you. And yeah, that was it for me.
Yeah, I'm so impressed with the tech setup and production there, because it messes with your head when you try and work out how to plug all these things without creating feedback loops and all kinds of problems. So yeah, amazing work over there.
And they pulled it off really nicely. So you know what the challenge is like.
Yeah, I know very well. And thank you to you, Federico, and also to Barrett, who helped organize but couldn't make it.
Barrett going at the wearable computing group here at the UDK.
Yeah, a special superhero of mine. Okay, so we haven't thanked everyone because there's so many things people to thank, but we'll close it there, leave it there, and say thank you to everyone and continue the discussion on the forum, which is forum.algorithmicpattern.org, if you like. But otherwise, enjoy the rest of your weekend. Take care, everyone.
Thank you. Bye.